Let's continue on our journey with functions. In this video, we will be exploring the domain and range, part 1. It's going to be a two-part video, and this is the first part. So let's get started. Okay, every function, every one of them, has a clearly defined set of input values called the domain, and a clearly defined set of output values called the range. Let's write that down. Every function has a clearly defined set of input values called the domain and a clearly defined set of output values called the range. Okay? So if we looked at our function box, x went in, we apply f to it, out comes f of x, also known as y. The things going in are our input values, now also called the domain. Things coming out are our output values, now also called the range. Okay? Now, whenever and from henceforth we talk about a function, we should be able to talk about its associated domain and range. Okay? Whenever we talk about a function, we should be able to talk about its associated domain and range. Okay? Now recall from the last video the 4 representations of a function that we explored. Do you remember what they are? 4 representations. Be a good time to quiz yourself of a function. The first was a list of ordered pairs or a table of values. Okay? The second was a formula. Some f of x equals y, where we had a rule that was easy to determine. The third was a graph, probably our most favorite as it's a visual explanation. And the fourth, a description in words. Probably the hardest one because it's like a word problem, translating a real-life application to some mathematical meaning. Okay, what you should be able to do is extract the domain and range of a given function regardless of which representation it is given in. So we need to be able to extract it from a list of ordered pairs, from a formula, from a graph, or description in words. In this video, we're going to explore how to find the domain and range if we're given the function as a list of ordered pairs or if we're giving it as a formula. In the next video, we will explore graphs and descriptions of words. Okay, so let's start with the list of ordered pairs. And this is probably the easiest one to pull off the domain and range. Okay? So we'll look at a particular example. Let's say we have the set containing the ordered pair 1, 3, 2, 5, 6, 8. So notice that my definition of a function is satisfied. For each first coordinate, there is exactly 1 second coordinate. Okay? The input, you recall, is the set of all first coordinates. So that's also our domain. So the domain here is the list of elements containing 1, 2, and 6. Now the range is the set of output. And remember, the output, given a set of ordered pairs, is the set of all second coordinates. So in this case, 3, 5, and 8. Okay? So again, if you're given a set of ordered pairs, The domain will be the set of all first coordinates, and the range will be the set of all second coordinates. Let's look at an infinite set and see how that we can answer that question. So here's another example. Let's say we have this set containing 1, 2, 2, 4, 3, 6, 4, 8. And we continue this pattern off forever. And hopefully you can quickly see what that pattern is. So I see that my domain in this case, it's infinite, so I can't list them all, but I recognize the pattern. 1, 2, 3, 4, and we see that we're going up by positive integer values, starting at 1. So my domain is 1, 2, 3, 4, dot, 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 tells me that I go on this pattern forever. Now the range in this case is the set of all second coordinates, and I see I start at 2, and I'm going up by even multiples of 2. So 2, 4, 6, 8, and so on. So given a set of ordered pairs, it's not too difficult to find the associated domain and range. We're usually not given it in that form. Often, or usually, we are given a formula, which is a bit harder. Okay, so let's look at an example. F of x equals 2x plus 5. This is an example of a linear function and should be familiar to you. So to answer the domain and range question, if it's in this form, is what is mathematically legal to plug into my function? And that answers the domain question. Okay, what can I plug in and I won't violate any mathematical rules? And then second, what type of numbers come out? And that answers the range question. So I look at this example. Let's draw a little function box because sometimes pictures help us put things together. X is my input that goes in, and out comes 2x plus 5. So the question you have to ask is, what can I legally put in here and produce a real number? So, is there anything that I cannot multiply by 2? No. Is there anything that I can't first multiply by 2 and then add to it 5? No. I can take any real number, multiply it by 2, and then add 5. This tells me that the domain is the set of all real numbers. Now the range is the set of numbers that come out. So I ask myself, is there any y value you can think of that you cannot solve for a real valued x? And the answer is no. Pick any y and you will be able to solve for x. Therefore my range in this case is also the set of all real numbers. I will have some videos that explore particular or different types of functions where we find the domain and range given a formula that are a little bit trickier than linear functions. But we now know what we're supposed to do to find the domain and range if we're given either a set of ordered pairs or if we're given a formula. In the next video we will explore graphs and functions as a description in words.